All right, so we are going to, in the next 3 sections now, start adding in more options for our identities. Okay, so this section, 6.2, is all about sum and difference identities, which on your paper you will find in the top right corner. There's 6 of them. These are the ones that have the U's and V's that we're going to be using. Again, those 6 are the only 6 that you need to worry about from, well, this week, actually. Those are the only ones we're adding in, okay? All right, so sum and difference identities allow us to calculate exact values for angles that are not on our unit circle. Okay, so let's say I asked you, what's the cosine of 165 degrees? 165 degrees. Okay, so that's not on our unit circle. At this point, what we would have done is typed in cosine 165 degrees in our calculator, and we get the decimal that goes with it. But 165 degrees, I can add or subtract 2 of my unit circle values to get to 165. I can add 120 and 45 to get 165. So if you can add or subtract 2 unit circle values to get a new value, that's what these formulas are for. The U and the V are 2 angles that are on your unit circle. And so these problems are the ones that we kind of talked about when we talked about the unit circle before, where I said you might have to do 4 or 5 unit circle values within one problem. Anywhere you see a cosine U or a cosine V or a sine U or a sine V, that's a place where you're finding something on your unit circle and filling that value in. Okay, so these are the ones for cosine, cosine, minus, sine, sine for both of them, or cosine, cosine plus sine, sine. Find the exact value of cosine 7 pi over 12. So 7 pi over 12 is not on our unit circle, but they're giving us a little hint here. They're saying 7 pi over 12 is pi over 3 plus pi over 4. Because it's plus, I am using the identity that has the plus in the parentheses. If I was subtracting my angles, I would use the identity that has the minus in it. Bless you. So we are finding cosine 7 pi over 12. And they're saying cosine of 7 pi over 12 is the same as pi over 3 plus pi over 4. If you add those together, you get 7 pi over 12. The pi over 3 is the U, and the pi over 4 is the V. So this tells you, when you use this formula, anywhere you see a U, you're going to put pi over 3, and anywhere you see a V, you're going to put pi over 4. So using the top formula, it looks like the following. Cosine pi over 3, cosine pi over 4, minus sine pi over 3, sine pi over 4. Okay, everybody following me? All right, now we're just going to find all 4 of those things on our unit circle. If I say find cosine pi over 3, that whole thing is going to disappear, and you're just going to replace it with one number from your circle. What is the cosine of pi over 3? It is a half. What is the cosine of pi over 4? Rad 2 over 2. Minus, what is the sine of pi over 3? And the sine of pi over 4. Okay. Then we simplify. We know how to multiply fractions, multiply the numerators together, multiply by the denominators. So numerators, I have rad 2 over 4 on the denominators. In my second set of numerators, I've got rad 6. Denominators are, again, 2 times 2, 4. I can put them together because they have a common denominator. Rad 2 minus rad 6 over 4. You cannot add or subtract radicals unless they are the same radical, which these are not. Rad 6 and rad 2 don't break down. Final answer. Do you have your calculators? I'll show you how you can check it. All right, so we're going to type the problem in our calculator, and we're going to type the answer in our calculator, and we're going to make sure the decimals match. The decimals should never be an answer that you give on a test or quiz, but you can at least use it to check. So make sure you're in radian mode, because we're typing a radian in. And then go ahead and type in cosine of 7 pi over 12 once you're in radian mode, which, let's see what that gives me. Cosine 7 pi over 12. Oops, no, I didn't type that in right. There we go. I got negative 0.2588-ish. Okay, and then go ahead and type the answer in. So square root 2 minus square root 6, and then divide the whole thing by 4. And you will see you also get negative 0.2588. You can match up the decimals and make sure they're the same, and that's how you know your answer is right. Okay, if it's degrees, just make sure you're in degree mode. Make sense? Any questions? Okay, let's try another one. Find the exact value of cosine of 15 degrees by using the fact that 15 is 45 minus 30. So cosine 15 is the same as 45 degrees minus 30 degrees. That's our u, and that's our v. This time, because it's minus, we're using the second identity, cosine u minus v. So the only thing that changes is I have a plus between my terms instead of a minus between my terms. Still cosine, cosine, sine, sine. All right, so cosine 45 degrees, cosine 30 degrees, plus sine 45, sine 30. What's cosine of 45? Rad 2 over 2. What's cosine of 30? Rad 3 over 2. Plus sine of 45. Sine 30. So my first set of fractions, if I multiply them together, I get rad 6 over 4. Second set of fractions, rad 2 over 4. Rad 6 plus rad 2 over 4. You're going to notice you're going to get a lot of the same numbers over and over again with these problems. That's because we're using unit circle values, and there's only so many numbers on my unit circle, a 3 over 2, a 1 over 2, and a 2 over 2. So when we combine those together, only so many numbers are going to pop out. So you're going to see a lot of rad 6s, a lot of rad 2s. Really, the pluses and minuses are going to be what make the biggest difference in your answers. And again, if you want to check this, just make sure you're in degree mode. Type in cosine 15, type in the answer, make sure the decimals match. Any questions on that? Yep.
Are we always going to end up with a common denominator?
Yes, you should for these. All right. Let's do sine now. Works the same way. Okay, so two more formulas. Sine, I remember when I have to memorize these. Sine has the same sign. So the one that has a plus is a plus between the terms. The one that has a minus is a minus between the terms. Sine is the same sign. Okay, other than that, we just find our u and v. We plug them in and we use our unit circle to evaluate. Most of the time, you will not be given what two angles need to add or subtract to get the angle you're looking for. Okay, so like 5 pi over 12 here, that's what we're trying to evaluate. It's obviously not on my unit circle, but we need to figure out what adds or subtracts to 5 pi over 12. I think personally it's easier to figure out what adds and subtracts if you're in degrees. So the first thing I'm going to do is take my 5 pi over 12 and just change it to degrees first. This is an optional step. If you feel confident with the radians, keep the radians. That's fine. 180 over pi. My pi's will cancel. 5 times 180 divided by 12. I get 75 degrees. Okay, so we are finding the sine of 75 degrees. Can you think of two angles that add or subtract from our unit circle to get to 75? There's a lot of different ways to get it. There's not one right answer here. What adds or subtracts to get 75 on our unit circle? Yep, 30 and 45. Try to stick with quadrant 1 if you can, because everything's positive. Occasionally you'll have to have quadrant 2 stuff in there though. Just depends what your angle is. Okay, so 30 is my U, 45 is my V. If you did 45 plus 30, you'd see you get the same answer in the end. Addition order doesn't matter. All right, so because this is addition, I'm using the formula on top. Sine 30, cosine 45, plus cosine 30, sine 45. Sine, cosine, plus cosine, sine. All right, somebody besides Holden. Somebody besides Holden. What is the sine of 30? Come on, guys. 1/2. Cosine of 45. Good. Cosine 30. And sine 45. Multiply them, I get rad 2 over 4 plus rad 6 over 4. Rad 2 plus rad 6 over 4 is my answer. Is this making sense? You guys have any questions? Put a rad 2 and a rad 6. Now, there's different options. Like, one of them could be negative, both of them could be negative, right? But it's going to look something like this, yes, if it's a sine or a cosine. Okay, I'm going to let you guys try this one, but just so we're all doing the same set of work, let's pick our two angles together here. And let's use subtraction, because we didn't use a sine and subtraction yet. So can you give me two angles on your unit circle that subtract to give you 195? Anybody think of a set that could work? Sorry.
240 minus 45.
That'll do it. 240 minus 45. All right, that's our U and that's our V. Order does matter with subtraction, so be careful. All right, I'll give you a few minutes. Okay. Answer. Negative rad 6 plus rad 2 over 4. How do we do? Good? If you had on the top rad 2 minus rad 6, it would be the same answer. Any questions? Just be careful with the negatives to get some bigger angles there. Okay. All right, so let's say now I give you cosecant of 195. All right, look at your identity sheet. Are there identities with the U's and V's for the reciprocals, secant, cosecant, cotangent? Nope. So we use, in combination with these guys, the reciprocal identity we already know. Cosecant is the reciprocal of which function? Sine. Okay, so this is the same as 1 over the sine of 195. And isn't the sine of 195 what we just figured out a second ago? Conveniently. Okay, so if you have a problem that is a secant or a cosecant or a cotangent, you're going to first use the sum and difference identity for its reciprocal, like sine. And then at the end, you just have an extra step. You're going to flip it. Okay, so we just found out it was, what was it, negative rad 6 plus rad 2 over 4. So if I flip it, it looks like 4 over negative rad 6 plus rad 2. So technically this is our answer, but what's wrong with this answer? Radicals in the denominator, and rationalizing isn't quite as easy as just multiplying by a radical over itself because there's two radicals down there. So to rationalize this, we multiply by a conjugate. Conjugate is the same terms, but a different sign between them. So it's going to be a negative rad 6 and a rad 2, but now it's a minus between them. negative rad 6 minus rad 2. Only the sign in the middle changes. On the bottom, you are foiling, but they're conjugates, so we know outside and inside are going to cancel. You only have to do first and last. What's negative rad 6 times negative rad 6? Negative. Well, negative times a negative is positive. So the negatives cancel. Rad 6 times rad 6 is just 6. And then what's positive rad 2 times negative rad 2? Negative 2. So the whole denominator is just 4. In the numerator, we are distributing. So I have, if I distribute the 4 and negative 4 rad 6 minus 4 rad 2, negative 4 rad 6 minus 4 rad 2. And then what do you notice about every term in that fraction? All of them have a 4 out front of the radical. So I can reduce this fraction by a factor of 4, which would leave me with negative rad 6 minus rad 2, final answer. If you want to check it, type 1 over sine 195 in your calculator, type the answer in the calculator, make sure the decimals match. Okay, so if you've got a reciprocal, it's just like an extra couple steps, and really flipping it is not difficult, just have a little bit of rationalizing that's kind of yucky.
Isn't that like the exact thing you multiplied by?
It is the exact thing I multiplied by. No. Sometimes your signs could be different, it just depends what I've got. Oops. Good question. Okay. Other questions? No? Okay. All right, next. All right. Evaluate without a calculator. These are going to look like the most complicated problems on your homework. They are the easiest. It is just asking you to realize what has been used here. They have filled in the difficult side of the identity already. So ignoring the 43 and the 13, just look at the form of what we have here. I have a sine, cosine, minus a cosine sine. Which of the identities we've talked about already is that? Sine, cosine, minus cosine sine. Yep, it's sine u minus v. Do you guys see that? That it's the complicated side filled in? You just need to recognize what the u is that they filled in, what's the v. We're using the easy side of the identity. What's the u that they used? 43. And what's the v that they used? And what's 43 minus 13? And what's the sine of 30? That's a unit circle value. That's my answer. That's why we don't need a calculator to do it. Okay? Good on that? All right, so if it looks messy, just try to work backwards with it. Let's look at this one. Okay, we are given a couple pieces of information. Sine of u is negative 3/5. Cosine of v is 12/13. So u and v are some angle. I know they're sine, I know they're cosine. I am also told that u is between pi and 3 pi over 2. And I'm told that v is between 3 pi over 2 and 2 pi. We are eventually going to do a sum and difference identity, but I'm not even going to worry about what it's asking yet. Okay, I'm just going to focus on all my given information to start, because this stuff is actually all just 90% review from what we did in the last chapter. If you are told that u, angle u, is between pi and 3 pi over 2, they're telling you what quadrant it's in, right? What quadrant am I in if I'm between pi and 3 pi over 2? I'm in quadrant 3. U is in quadrant 3. Okay, so I'm just going to focus on u right now. If I know that u is in quadrant 3, I can draw a triangle in quadrant 3. And that triangle, right angle on the x-axis, angle u is near the origin. That angle has a sine of negative 3/5. So that helps me label my sides. Opposite is 3. Hypotenuse is 5. Which one makes sense to be negative? 3. And this is actually one of our special triangles. What's the missing side? Close. Got to be careful with our negatives. It is -4 because we're in quadrant 3. We're going to do the same thing for v. V is between 3 pi over 2 and 2 pi. So where is it at? It's in quadrant 4. All right, so I'm going to draw a triangle. In quadrant 4. Label it V. What do I know about V? I know its cosine, adjacent over hypotenuse, is 12/13. This is also a Pythagorean triple if you recognize it. If not, we use a Pythagorean theorem. It's 5, close, -5. Okay, so that is all just given information, draw triangles back from chapter 5. Okay, now let's look at the problem. The problem says find the sine of u plus v. We do not know what u is, and we do not know what v is, so we can't just plug numbers into here. You have to use the identity. Sine u plus v is sine u, cosine v, remember sine has the same sign, plus cosine u, sine v. Sine, cosine, plus cosine, sine. And again, those 4 things we're going to fill in. We just don't know unit circle values. We're going to find them off of our triangle. What is the sine of angle u? Look at the picture or look at your given information. The sine of u is -3/5. That was given. And cosine of v was also given to us. It was 12/13. Plus, now here's what we need the triangles for. I wasn't given the cosine of u, but I can look at triangle u and find the cosine. What is the cosine of u? -4/5. And the sine of v, we look at triangle v and we find the sine, -5/13. If I multiply them, I'm going to get -36/65 plus 20/65. Final answer is -16/65. Yeah.
I just have a question on how we got, like, what quadrant they're in.
So you can always convert these to degrees if you want to. Like 3 pi over 2 is 270, and 2 pi is 360.
Oh, okay.
Right?
Yeah.
Okay. It's sometimes harder to see with the radian. I get that, yeah. Other questions on this slide? Okay, the next problem looks different, but it's actually the same as what we just figured out a second ago, believe it or not, okay? So, sine of inverse tangent of -3/4 plus inverse cosine of 4/5. Again, review from chapter 5 is, if I have an inverse function, the answer to that is an angle. Like if I told you before inverse tangent of, I don't know, 1, then you would work backwards and say it's 45 degrees because it's the angle that gives us that tangent, right? Okay, so we're just going to call these angles that we need to figure out, conveniently, u and v, okay? So do you see the sine u plus v identity in there? Okay, and we're going to draw the pictures, but first we need to figure out what quadrant they're in. You need to remember inverse functions, what quadrant they're defined in. Do you remember which 2 quadrants inverse tangent is defined in? 1 and 4. If my tangent is negative, am I in quadrant 1 or 4? 4. So u is in quadrant 4. And its tangent is -3/4. Same information I was given in the last problem. I've got a quadrant, I have a trig function. Okay, v is an inverse cosine. Inverse cosine was defined in what 2 quadrants? 1 and 2, but my cosine is positive, so I am in quadrant 1. Okay, let's draw our 2 triangles now. U is in quadrant 4, and I know its tangent, opposite over adjacent, is 3/4. One of them is negative. Which one makes sense to be negative? 3, -3/4. What's the missing side? 3, 4, 5. Okay. And then I'm going to draw this so they don't intersect each other. V is in quadrant 1, and its cosine adjacent over hypotenuse is 4/5. What's the missing side? 3, all positive. Okay, so now sine u plus v is our goal. And we have u and we have v drawn. Sine u cosine v plus cosine u sine v. Find all 4 of them. What is the sine of u?
-3/5.
Yep. Cosine of v. Yep. Cosine of u. Four over 5. Sine of v. Three over 5. So I have -12/25 plus 12/25. My answer is 0. Okay, good. Any questions on that one? Really similar to the one before, just to give us different information in a different format, I guess. Okay, last slide for today. Proof. These proofs should be the easiest proofs that we have done so far because they are telling you what to start with. Okay, if you see 2 angles inside a trig function that are added or subtracted, you do not have a choice. You have to use the trig identity for sum and difference. You may not distribute a function in. That is not a thing. Okay, only if that sign on the outside had like an X next to it are you allowed to distribute it in. Okay, but we just have 2 angles. So think of this like our U and V identity here. Okay, I'm going to play with that side a little bit. I'm going to expand it. So everywhere I see a U, I'm going to put a pi in the identity. And everywhere I see a V, I'm going to put an X in the identity. So that would look like sine U, so pi, cosine V, so X, plus cosine U sine V. Okay, so pi's and X's instead of U's and V's. Again, there's not something you really have to think about here. Sine of pi and cosine of pi are things that you should be able to find numbers for. That is unit circle stuff. What is the sine of pi? It is 0 times cosine x. What is the cosine of pi? -1 times sine of x. And 0 times anything is 0. And -1 times sine is, and that's what I have on the other side. And that is the end of my proof. Okay, so I see those 2 angles added or subtracted. First thing I'm doing is using my sum and difference identity, and then just simplifying where I can. Last problem of the day. One more proof. Cosine x plus y over sine x sine y equals cotangent x, cotangent y, -1. As soon as I see 2 angles added or subtracted, that's my first step. Sum and difference identity, this time it's a cosine. So instead of u's and v's in my formula, I'm just plugging in x's and y's. So in the numerator, it's going to look like the following. Cosine x, cosine y, cosines have different signs between them, minus sine x sine y over sine x sine y. Am I allowed to cancel those sine x sine y's? Because does every term have a sine x sine y? No, but it would be really nice if I could cancel them, right? So I'm going to separate what I have into 2 separate fractions. As long as they have the same denominator, I'm allowed to do that. So cosine x cosine y will be over sine x sine y minus sine x sine y over sine x sine y. And you can see if I subtracted those, they have a common denominator, I'd be right back where I started. Those are equivalent expressions. But now because I split it, I can cancel. And if I cancel something over itself, what am I left with? All right. And on the other side, everything's multiplied. So you could even split it up a little bit more and say I've got this fraction times this fraction. That's equivalent. Oops, that's a sign there. What's a cosine over a sine? Cotangent. And then cotangent y minus 1. That's what I have on the other side. And that's the end of our proof. Tomorrow, we only have 3 slides, and it's just practicing the same sort of stuff with tangent, because we didn't do the 2 tangent identities yet, and then that's it. And that's the only new lesson for this week. Okay, so you have, yeah?
Are we doing a lesson on Tuesday this week?
Yes, we are. I know some of you have your ACT. So actually the homework on Monday night, we're going to do the first part of the lesson on Monday during the day. I'm going to get through as much as I can. Whatever we don't finish on Monday, the only homework Monday night is to watch the rest of the lesson at home. And then Tuesday in class is actually a work day on that lesson. So even you could watch the video lesson on Tuesday night if you wanted to watch it after, as long as when you come back Wednesday, you've watched both part of the lesson. If that makes sense, okay? All right, so the last 10 minutes are yours. You can check things in the binder. You can ask me questions. You also, as I've warned you before, have a 6-2 set of questions, okay? These and the 6-1 packet are due Friday after you guys do your quiz, okay? So tomorrow, like I said, it's just 3 slides. On Thursday this week is just a homework work day in class. You all have a whole day, just practice, ask questions, check answers. And then you can just be working on this at home. Remember, these packets are graded partially for correctness, here, partially for completion. So do your best. If you want me to check anything at any point in time, I can do that. All right, there you go. You guys can pretty much do all of this if you want to. And try the tangent ones.